All right, here we are, Unit 3. Let's go through the logs practice test for our tests on Wednesday and Thursday this week. Sorry we have this up a little late. The holiday kind of threw us off, but we'll hit right up, get through it right now. All right, so here we are at problems 1 through 6. So all these are just evaluating our log functions. So you can basically think that each one of these equals x in each one, so you can figure it out. So the best way to evaluate a log that we learned in class is to make it an exponential. So here we have our base value of 4. So this would be 4 to the x power equals 1. Well, the only exponent I know that gets me to 1 would be 0. So x has to be 0. Here, same thing. Now, when there's no base here, the base is 10. So this would be 10 to the x equals 10,000. So 10 to the x, you might know this right away, but you can also think of this as, so there's 1, 2, 3, 4 zeros. So this would be the same as 10 to the 4th power. So since they are the same base, x must be 4. Bam, right there. All right. Here we are here. All right, 1/3 log of 1/3 of 81. So this would be 1/3 to the x power equals 81. All right, so thinking of this way, 81 is 3 to the 4th. Okay, so 3 to the 4th, if I want to make this 3 to the 4th, I can make this a negative exponent, because a negative exponent makes a fraction into a whole number into a fraction. Okay, and so how this works then is you could sit there and say, all right, well, negative x must be 4, so x has to be negative 4. Okay, and here we have log 4 of 16. So again, we have 4 to the something power equals 16. So here's 4 to the x equals 16. Well, that must be 4 squared, because 4 to the x equals 4 squared. X equals 2. Bam. All right there. All right, and then 5. 5, I have 3 to the x power equals negative 8. Well, there is no way I can get a negative number by taking something to a power. Because you can't multiply something so many times that it eventually becomes a negative. It just doesn't work that way. Because you can think about what 3 to the x would look like. So 3 to the x looks like this, as we know from graphing it in class. And there's an asymptote here at 0. So there's no way for this thing to cut loose. So this would be no solution, or not possible, or undefined, however you want to write it. Log 5 of 0, same idea, because here we have 5 to the x equals 0. Well, there is no exponent that I can take 5 to that's going to get me 0, because there is this asymptote at 0. So this would also be no solution to that problem. All right, that was a nice kind of easy way to start it through. Okay, here we have some fun actual equations. So here we have log of 2x equals 3. So there is no base here, so it's a base 10. So this would be 10 to the 3rd power equals 2x. So 10 to the 3rd, that's 1, 2, 3 zeros, equals 2x. Divide by 2, and x equals 500. Nice. All right. Same thing here. All right. So now this is not just a simple log function, but in order to make a log an exponential, I need to just get the log itself by alone. So that means I need to move this -1 and this 2 to the other side. So I'm going to add 1 here. So I'm going to get 2 log x 16 equals 8. And then I'm going to divide both sides by 2. And I'm going to get log base x 16 equals 4. So that would mean x to the 4th is 16. Well, 16 is, I can rewrite, so x to the 4th equals 2 to the 4th. So x has to be 2. Okay? The key thing there is you cannot convert it to exponential form unless you get just the log by itself. So we need to get just this section alone. Okay? So here, I just have log x of 1/64 by itself. So in this one, I can convert it right away. So I get x to the 3rd power equals 1/64. Okay? So I can think of this as basically 1 over something. So 64, I can rewrite this as 1 over 4 to the 3rd. So, because 1 to the 3rd is just 1, so this could be 1 to the 3rd and 4 to the 3rd. So x would then be 1/4. So some of these you might have to just play around a little bit on your calculator to maybe figure them out. I'm going to go through this kind of quickly so we can get through it all. So here we have 3 squared to the x equals 81. So our exponent laws means we multiply those two things. This is 3 to the 2x equals 81. So here I have 3 to the 2x. Now we've known from before that 81 is 3 to the 4th. So here I get 2x equals 4 and x equals 2. Bam. All right. Okay, here we go into our word problems. Now we are going to need to know these formulas for the test, so definitely make sure you have them in the back of your mind. It should be kind of similar to what we did when we were doing geometric sequences, so that should help you in your setting up your formula. So here we have your parents buy you a new car for $25,000. How nice of those parents. The value of the car depreciates by 11.5% each year. In how many years to the nearest 10th will the car have a value of 10,500? So in this situation, we do need our graphing calculator. So here I have my 10,500, so that is my current value of the car. 25,000 is what I started with the value of the car, and it's 1 minus, so the appreciation each year is 11.5%, so that's 0.115, and I'm taking that to the t power for time. Okay, all right, so here we can divide both of these sides by 25,000. And if I do that, my trusty little calculator, so 10,500 divided by 25,000, and I get 0.42. And this equals, well, 1 minus 0.115 would be 0.885 to the t power. So now I need to get this down. The only way to do that is to convert it to log form. So I'm going to do just that. I'm going to bring it over here and convert it to log form. So I get t equals the log of base 0.885 of 0.42. And I just have to plug this into my nice little calculator. So here I get log base 0.2, and I get 7.10 years. Remember, time is continuous, so you can have part of a year, so definitely do put that decimal if it's there. Okay, so it takes about 7 years for your car to be worth $10,500. That is not a very long time at all. All right, so here we have Kelly, who plans to put her graduation money into an account and leave it there for 4 years while she goes into college. She receives $750 in graduation money that she puts into account that is 4.25 interest compounded semi-annually. So remember, semi-annually is 2 times a year. So how much will be in Kelly's account at the end of 4 years? So this time we do not know what the ending amount is. So she starts with $750. 1 plus, so here's 0.0425, and I am compounding that twice a year, and 2 times a year for 4 years, that's going to be 8 total times up in that decimal. So I get 750 times 1, what is this, 1.02125 to the 8th power. So if I do this, power times 750, she at the end of 4 years should have $887.40. Okay? Because we are earning 4% interest, so remember, this is yearly interest. Okay, so this is for the year. So you do, when it's compounded semi-annually, you do need to cut it in half because you do, so it's 2 equal payments a year that are going to add up to that 4.25%. Okay, and then if you're going to do that twice a year for 4 years, you also need to make sure you multiply up here in the exponent. So that 2 goes into 2 different places in our formula. So we need to make sure we think through that as we look through this. Okay, all right, now let's do some graphing. Okay, so here we have our exponential equation. All right, so my parent function of our exponential equation would be y equals 3 to the x. Okay, so that should have anchor points of 0, 1, and 1, 3. Okay, so these are my initial points. All right, so as we now move through this, we want to list the transformations. So let's list our transformations. So in order of what we're going to do, first we're going to go to the right one. Secondly, I'm going to stretch at 5. Third, I'm going to reflect it over the x-axis, making sure we know which way we are reflecting this over. And then lastly, I'm going to move it up 5. Okay, so each one of these points, I'm going to do each one of these steps too. So right here, I'm going to go to the right one, and then I'm going to stretch it 5. So 1 times 5 gives me 5. I am then going to reflect it over the x-axis. So here I'm at -5. Right? 1, 2, 3, 4, 5. Okay, so it's just hard to see sometimes. All right, and then I'm going to go up 5. So right there, my new point. Okay, so I'm going to do the same thing here. Go to the right one, multiply it by 5. So I'm way up at 15. I'm going to reflect it. So I'm way down here at 15. -15, and then I'm going to go up, so now I'm at -10, so 2, 4, 6, 8, 10, yep, and I am right here. Okay, and my asymptote, so it was at 0, but then I moved the whole graph up 5, so the new asymptote is going to be at 5. So I know I can't go through that, so I must be able to go just by it and then through my new points right here. Bam. There should be my graph. Okay, so my domain comes -infinity to +infinity. My range is from -infinity to 5, my new asymptote. So my new asymptote is y equals 5, making sure we get the y equals there. All right, my root, well, root is when y equals 0. So we could plug this into a log function, but actually you do see that right here is 0, 1. I'm sorry, 1, 0 is my root. Okay, and if we were to do that, 0 equals negative 5 to the 3 x minus 1 plus 5. Okay, so converting this to log to solve this through, then I divide both sides by negative, so I get 1 equals 3 to the x minus 1. And right here, I get x minus 1 equals log base 3 of 1. Well, the only way to get 1 in a log means that this has to be 0, so I get x minus 1, x equals 1. Hey, yay, set up right there. Okay, but on this graph, it's pretty much easy. You don't even need to do all that work. Okay, and then our y-intercept, well, I'm just going to plug 0 in for y. So I'm going to do that over here. So let's see, y equals negative 5, 3 to the 0 minus 1 plus 5. So negative 5, 3 to the negative first power plus 5. So 3 to the negative first is 1/3. So this is 5 times 1/3 plus 5. So this would be negative 5/3 plus 5. 5/3 plus 5 in terms of 3 is 15/3. So this would be 10/3. 0, 10/3. Bam. So you do have to do a little math on those intercepts, but shouldn't be anything that we can't do. Remember, y-intercept, I'm plugging in 0 for x. Roots, I'm plugging in 0 for y. And looking at our problem. All right, let's do a log one. All right, so here we have our log one. So here my base, so my standard equation would be y equals log base 2 of x. So that would mean I would have the point 1, 0 always, and then my base 2, 1. So I would start here and here as my two anchor points. All right, so then let's list our transitions. So here I'm going to go to the left 4. Here I'm going to then reflect over the x-axis. And 3, I am going to go down 3. Okay, so each one of these points, so from here I'm going to go left 4, so 1, 2, 3, 4. I'm going to reflect, well 0 times negative 1 is still just 0, so I stay right here, and then I'm going to go down 3, and here is my new point. Do the same thing here, go to left 4, 1, 2, 3, 4, reflect, boom, and then I'm going to go down 3, 1, 2, 3. There she is right there. And my new asymptote, so it was at x equals 0, so now it doesn't move up or down, it moves left or right. So I'm going to focus this guy, this left 4, that is my new asymptote. And I am going to drop my graph. Sorry, yours should not be as wavy as mine is, and it should look just like this. So the domain then goes from negative 4 to infinity. The range, negative infinity to infinity. My asymptote is now x equals negative 4, vertical line. The roots, all right, the roots and then the y-intercept. So we got to do our math again. All right, so the roots would be 0 equals negative, log base 2 x plus 4 minus 3. So again, I got to get rid of this negative and this 3, so bring the 3 over. 3 equals negative log base 2 x plus 4. Divide by negative 1, and I get negative 3 equals log base 2 x plus 4. Let me show you. Should probably show my work of what I'm doing. All right, so I get negative 3. So now that it's just a log function, I can put it into exponential form. So 2 to the negative 3 equals x plus 4. So I get 2 to the negative third power. So this would be 1/8 equals x plus 4. Subtract the 4 over. So 4 in terms of 8, I get 1/8 minus 32/8. So I get negative 31/8 is my root. Man, that is a ugly root. Y-intercept, let's hope that's a little nicer. We get negative log base 2 of 0 plus 4 minus 3. Okay, so again, let's move this 3 over. So I get y plus 3 equals negative log base 2 of 4. All right. I can get this so that it'd be negative y minus 3 equals log base 2 of 4. Well, this is not gonna, oh, it is going to help me. So, because here I get 2 to the negative 3, or negative y minus 3 equals 4. Well, 4 is 2 squared. So I get negative y minus 3 equals 2. And so I add 3. And I get negative y equals 5. Y equals negative 5. 0, negative 5. It's my y-intercept. Some of you might have seen right here, log 2 of 4. If you could figure out in your own head that log 2 of 4 is just 2, by all means, you could have substituted it there and saved yourself work converting it to the exponential. But I was just showing, in case you didn't see that, moving it to the exponential does actually help you in that problem. All right. Last one, we want to find the amount of interest earned on $5,000 at 2.5% compounded quarterly over 6 years. So, again, we're just doing another interest problem. So here we have $5,000. 1 plus 0.025 dot quarterly. This is 4 times a year. So it's 4 times a year for 6 years. So I get 5,000 times, I get 1 plus 0.025 divided by 4. Here gives me my multiplier of 1.00625 to the 24th power. So to the 24th times 5,000. And we get $5,806.46. Now the key part of this problem is understanding that they didn't want the end, they wanted the amount of interest. So if at the end of the day I earned $5,806.46 and I started with $5,000, I need to subtract to find the difference, would be $806.46. That is the amount of interest that I made. So make sure, the reason we put that on there is to make sure that we're reading the problem, because a lot of times on the test we're asking you something just slightly different and you need to be able to read the problem to know what's happening. Alright, so I hope this was helpful, and definitely see your teacher and go through the stations. on anything that you might have been a little confused on and want extra practice on. And good luck.